Here are the video notes for lesson 1.6. We're going to look at our library of parent functions, mostly just what are all of our parent functions, and that's going to lead into how can we shift them, how can we transform them, either up, down, left, right, or shrink or stretch. And just like in lesson 1.5, I already have the notes posted to Google Classroom, so some of the note slides I'll just talk about briefly and then keep moving to get to some examples. So the first one here, we have our linear functions, and then we get a little bit more in detail what these linear functions are. And so here we have y equals 2, that would be horizontal. So it's linear, but it's just a horizontal line. Something like if that was 2 up here, our line just goes through it horizontally. And then we have our identity function here, which is f of x equals f of x equals x, same thing as y equals x, and that just has a slope of 1 and passes through that 0, 0, that origin point as it travels through. Just a couple of different ones that I wanted to point out there, the difference between the constant function y equals a number and then y equaling x, or f of x equaling x. The next parent function would be x squared, making this parabola down here. Then we have our cubic function, x cubed, making this sort of spaghetti noodle shape where it goes, it's increasing, it kind of flattens there and then keeps increasing. Has the symmetry around the origin. Our square root function, where we have just the positive side of things for our square root function. If we added the negative side of things, all of a sudden it wouldn't pass the vertical line test. So really we just look at the positive side of the square root function. We have our absolute value function. Again, make sure you're taking notes on really the domain and the range and what makes each one special. But again, I don't want to talk about them all because you can go through the notes in the written section and write these down. But our absolute value function looks like a v. It's pretty similar to a square function, but we have the v shape, not the parabola. Our reciprocal function, 1 over x, one of my favorite ones. We get this interesting shape from negative infinity to 0. We have this disk decreasing, then there's a break in the graph, and from 0 to positive infinity we have it also decreasing. Really interesting there. And then lastly, the step function here, and this is the one that we're going to spend some time on doing some examples here. The big thing to take away is we always want to round down. We're pretty much always rounding down our function. And so you can see when you put 1.5 in here, it rounds down to 1. When you put negative 1 in there, it stays negative 1. And we're going to go through some examples right here. And so the first one I've already done, and we'll just talk about. You put in 4.8 in the double bracket, meaning it's kind of putting it into your greatest integer function, okay? You put that 4.8 in your greatest integer function, and it goes down to the next biggest integer. So it goes down to 4, okay? And you can see if it's at 4.8, it goes down to 4. Okay, now if you put in a negative 4.8, it goes down again to the next biggest function, but because it's negative, we have to go down. So if you're at negative 4.8, it goes down to negative 5. Okay, so if it's in the positives, it always goes down. If it's in the negatives here, it looks like it's going up, but really it is still going down. Looking at the number line, it's going down to negative 5. So we'll see another couple here. Okay, so we're going to use our function here, and we're going to plug in negative 1, 2, and 3 over 2. So our x's are going to be negative 1, 2, and 3.5. Plugging in negative 1, we get double bracket negative 1 plus 1. Again, that negative 1, it's already at a whole integer, and so that's going to stay at negative 1 plus 1. It's going to give us 0. Okay? Plugging in 2, double bracket 2. It's already at 2. It doesn't need to round down, just like the negative 1 didn't need to round down. And so we just say that's 2 plus 1, and that gives me 3. Now we finally have 1 with 3.5, or sorry, 3 halves here that we're going to need to do the rounding. So if we plug it in, double bracket, 3 over 2 plus 1, Well, that's the same thing. 3 over 2 is the same thing as 1.5, so that's double bracket 1.5 plus 1. And because it's positive, we're going to round down here. We always round down, but it looks more like rounding down when it's positive, and that's going to round down to just 1. So I get 1 plus 1, and that gives me 2. And you can see here, that gives me 2, and I think I also had, I got a 3 from here, but we'll see examples where we're going to have overlapping, where we're going to get similar outputs. Okay, we'll do another one here, a couple more decimals to help us see it. We have double bracket here. Again, our x's are going to be what they give us, and that is -2, 3.5, and -2.4. Okay, plugging in this x for -2, double bracket, -2 minus 2, double bracket. That's going to be 0 plus 5. 0 is not going to round up or down because it's a whole integer already. So that's going to be 0 plus 5, which is going to give us 5. Now we have double bracket. We're plugging in 3.5 now for x. We have 3.5 minus 2, double bracket, plus 5. That is going to give me, the double bracket. 3.5 minus 2 is 1.5 plus 5. Positive 1.5, so we're going to round down here to 1. And so we get 1 plus 5, which is going to give me 6. Okay, -2.4. So now we're going to plug in -2.4 minus 2 in my double brackets plus 5. -2.4 minus 2 is going to give me double bracket still, -4.4, adding 5. And here, this is an example where if I put it on a number line again, we have 0, we have -4.4. We're rounding down, but that means we're going to round down to 5. Because if you looked at the number line, we're always rounding to the left. Just like in the 1.5, we rounded down to 1. Here we're rounding down to -5. And so this is -5 plus 5, which gives me 0. Okay, so again, that's just plugging in 3 different x values into some kind of function. And again, that function is called that greatest integer function. Or I like to call it that step function, but that double bracket's really the greatest integer. Okay, let's see one graph, and let's do this graph here. And so I'm just going to choose some x values to plug in to get a picture of what my graph is going to look like. And so let's do x equaling, let's do -2, -1.5, -1, -0.5. And let's see what kind of picture that gives me. So plugging in -2. And remember, these are step functions, so we should see something like we see here in the bottom corner. That's kind of what our general step function looks like. So I'm going to plug in -2, double bracket, -2 plus 3, and on the outside is a plus 2. That's going to give me 1 in the double. We're not going to round that up or down, so that's just 1 plus 2, and that's going to give me 3. So -2, 3 is a point. -1.5 we're going to plug in now. -1.5 plus 3, double bracket, plus 2 on the outside, and we're going to get -1.5 plus 3 is going to give me a positive 1.5 plus 2. And we're going to round that down because it's in the double bracket, greatest integer function, and it's going to round down to 1 plus 2, which is going to be 3. So I have 3 there. Another 3 at 1.5. Plugging in -1 now. -1 plus 3. That's going to give me the greatest integer 2 inside now, plus 2, 2 is not going to have to round up or down because it's already a whole number. And so you get 2 plus 2 equaling 4. And at that one, you get 4. So we're up here now. And lastly, we're going to plug in this negative 0.5 plus 3 in the double brackets, plus 2 on the outside. That's going to give me a positive 2.5, still in the double brackets, plus 2. Now 2.5 is not a whole number, so it's got to round down, and that's going to round down to 2 plus 2 equals 4. So I get 4. And you can see what I meant when I said I get double outputs here. Plugging in these numbers, because I'm rounding down, is creating this situation where I'm getting the same output multiple times. And what it starts to look like, and I could keep going, but for the sake of the time, what it starts to look like is, well, you would hold constant here, and then you would hit 3 and you'd have an open dot. Because it's going to pick back up at 4 when you hit negative 1. So then you can draw the line and you can create the open dot. And that's going to happen at each interval of 1 here. So like from negative 3 to negative 2, we're going to have a dot at negative 3. It's going to extend because of the greatest integer function always rounding down. And then as soon as you hit 2, it's going to make the jump up because you finally hit a new complete integer, a new whole integer. And so it keeps happening all along the graph, and it looks something like this. And you can see the similarity between that and my function down here in the bottom right. It hits a whole integer, so it's got a dot there, and then the greatest integer function always keeps it where it needs to be, holds it kind of constant there, and then as soon as it hits the next whole integer, it makes a jump up. And it's just because of that double bracket always rounding down until you hit the next whole integer. Okay? I have the homework assignment here. I believe I have it in this one. Oh, I do not. In the one that I posted on the Google Classroom, I have the updated homework. So look at the written notes one, or maybe I'll just make a post about what the homework is. Again, if you have any questions about the step function or parent functions, or I think we'll get into transforming them in the next lesson, but any questions on a parent function, I know this right here wraps it up pretty well, but please email me and ask, and I'm more than happy to do further explanations.